In this section, we will talk about absolute value equation and inequalities. Okay, so equation and inequalities involving absolute value. Okay, so here let's define our absolute value equation. So here we have an equation, absolute value of x equals to positive number a is any positive number, okay, greater than 0. So this is an absolute value equation, right? So we have this absolute value expression, we have equals to sign, and this is absolute value equation. Now in order to solve this absolute value equation, we have to get rid of absolute value sign, okay? And so in order to rewrite this without absolute value sign, we will have, so you will write whatever you have inside the absolute value sign. So we have x equals to positive of this number, or x equals to negative of that number. So whenever you get rid of this absolute values sign, then you always have two equation, okay, you always get two solution. So this is the definition, and we will use this definition to solve any absolute value equation. Okay, let's go ahead and start an example. So here we have absolute value of 2x minus 3 equals to 7. So this, at first, this is absolute value equation. We want to solve this equation. It means we want to find the value of x. Now the very first step is we will rewrite this equation without absolute value sign. Okay, for that you just write down whatever you have inside this absolute value sign. So we have 2x minus 3 equals to positive of number on the right side, which is 7, or you will have a two equation. Write down the same expression, 2x minus 3 equals to negative of a number that you have on the other side, negative 7. So every time, okay, if you have absolute value equation, you get these two equation, okay. Whenever you rewrite your absolute value equation without absolute value sign, you always get two equation. Now what type of equation we have here? These are the linear equation, right? And we know how to solve this. So let's solve this linear equation. You add 3 for this equation. So we have 2x, this is 0, equals to 7 plus 3, 10. Divide by 2 on both sides. We have x equals to 5 from first equation. In the similar way, let's solve second equation. You add 3 on both sides. So we have 2x equals to negative 7 plus 3, negative 4. Let's get rid of 2 by dividing by 2. And from this we have x equals to negative 2. So our solution for this absolute value equation is x is equals to 5 or x equals to negative 2. Okay, so whenever you have absolute value sign, you have to rewrite that equation, okay, without absolute value sign. And when you rewrite, you always get two equation, okay. Any question on this part? Okay, now we have a part B where we have absolute value of x equals to negative 3. We have to solve this equation, okay. Now we use the same definition. So write down whatever, okay. Now here, so we have absolute value of x equals to negative 3. Now we need to find the value of x, right? So for what value of x, its absolute value will be negative 3. Can you think of a number whose absolute value is negative 3? Or, so let's say in a different way. So what is the distance of a, okay, now can you think of a number whose distance from 0 on a number line is negative 3? For let's think of a number, okay, whose distance from 0 on a number line is -3. Its distance, the distance of that number has to be -3. Can you think of that number? What is the number whose distance from 0 on a number line is -3? So you have a number line, right? So we are trying to find a number. Okay, we are trying to find a number whose distance from 0 is -3. -3. Okay, now at first we have a, now can distance be -3? Do we even measure our distance using a negative number? No, right? The distance has to be always positive. No matter what number we pick, the distance is always positive. It means this equation does not have a solution. Okay, we cannot find any number whose distance from 0 on a number line is -3, because distance has to be positive. Okay, so in our definition, so if we go back to definition, so here we have absolute value of x equals to a, and this a has to be greater than 0. A has to be positive. Okay, since the distance is negative, which is not possible. Okay, distance is always positive, so this equation has no solution. So if you have absolute value of any expression equals to negative number, it's always no solution. Okay, now let's go to part C. So in part C, we have negative of absolute value of 3x plus 1 minus 3 equals to -8. Now we do have a like terms here before we use the definition. So -3 and -8, these two are like terms. So let's collect these two terms together by adding 3 on both sides. So then we have negative absolute value of 3x plus 1 equals to -5. Okay, now we still have negative in front of absolute value sign, and to get rid of this negative, we divide, or you can multiply both sides by -1. After this, we have absolute value of 3x plus 1 equals to +5. Okay. Any question up to here? We are not done yet here. Okay. Now you have to keep in mind that we use this definition. Okay, so we use that definition when you have absolute value of some expression equals to positive number. Okay, then only you can use this definition. And here we try to rewrite our equation as a absolute value of some expression equals to positive number. Okay, and if you have an absolute value of some expression equals to some positive number, then we can use this definition. Now let's go ahead and use this definition. So according to the definition, you write down whatever you have inside the absolute value sign, which is 3x plus 1 equals to, take positive number, +5, or we always get two equation. Then write down the same expression, 3x plus 1 equals to negative of that number on the right side, which is -5. That's how we get rid of absolute value sign. Okay, always write down your equation such that absolute value of expression is equal to positive number, then rewrite that equation without absolute value sign using the definition. Okay, now we have a linear equation. So let's solve this linear equation. You subtract 1 on both sides. We have 3x equals to 4. Then let's get rid of 3 by dividing by 3. And we have x equals to 4/3. In the next equation, very similar, subtract 1 on both sides. So we have 3x equals to -6. Let's get rid of +3 by dividing by 3 on both sides. And our x is equals to -2. So we have these two numbers as a solution for this absolute value equation. Okay, always before you use the definition, you must have absolute value of some expression equals to positive number. Okay, that is the condition to use this definition. Once you have that form, okay, so once you have this form, then you rewrite the same equation without using absolute value sign, and you will always get two equation. Do not forget, okay, always get two equation. The only difference is that on the right side you have positive number, on the left, on the other equation you have negative number. Okay, and the expression on the left side, it remains same. Okay, so this is how we solve absolute value equation. Okay, any question on this part? Okay, now let's go ahead and do the next one. Okay, so next here we have absolute value inequalities. Okay, so absolute value inequalities. So in our yesterday's class we talked about linear inequality, right? Now here we have absolute value inequality. So here we have this absolute value inequality. Okay, just let me rewrite this. So we have absolute value of x less than a. We can have less than, okay, do not forget, okay, if we have a less than, greater than, less than equals to, greater than equals to, not equals to. So if we see this sign on any mathematical statement, that is an inequality. And in this case we have this absolute value expression and we have inequality, and this makes absolute value inequality. Okay, now we have this absolute value inequality, and the definition is that to solve this inequality we have to rewrite this absolute value inequality without absolute value sign. Okay, for that you write down whatever you have inside this absolute value sign. Okay, write down x, then greater than this negative of this number, negative a, less than positive of this number, positive a. And this is how we can rewrite same absolute value inequality without absolute value sign. Okay, now what kind of inequality is this? What do we call this inequality? This is a linear inequality. So we had absolute value inequality. Okay, then we rewrite this absolute value inequality in linear inequality, and this is how we rewrite. Okay, write down whatever you have inside this absolute value of sign. Okay, then always greater than, if you have equals to here, make sure greater than equals to, then negative of this number on the left, less than positive of this number here. Okay, so this is the definition for this case. Now yes, that is the next definition. So if you have less than equals to, then the only difference here is that you will have greater than equals to and less than equals to. Okay, definition is exactly same. If you have equals to, make sure you have equals to. Now the next, if we have greater than, so if our absolute value inequality has greater than sign, so if we have absolute value of x greater than some positive number, or you can have equals to, it's gonna be same. If this is the case, then our definition, we have to rewrite this absolute value inequality in a linear inequality. For that you write down whatever you have inside this absolute value sign, x, then less than negative of this number, negative a, or then write down the same expression, x greater than positive of this number a. And this is how we can rewrite absolute value inequality in terms of linear inequality. Okay, this is the definition, and on your formula sheet I will provide this definition, but you should know how to use this. Okay, you don't need to memorize this. Okay, you will have this definition, but you should know how to use this definition. Okay, now let's go ahead and do examples here. I'm sorry?
We write it together like in the first one.
No, so this is or. Okay, now here, so what's the difference between this and this? So we can also rewrite this. This is same as x less than negative a, and like we did yesterday, x sorry, this is greater than, not less than, x greater than negative a and less than positive a. So here we have and it's or. Okay, so it's the difference here, and we'll see this in an example as well. Okay, so here we have this. Okay, at first you should know what is this. So this is absolute value inequality. Okay, now once you know what is this, now you look for what type of inequality sign you have. So we have less than or equals to, right? Now let's go back to our definition. Now we look for less than, the very first definition. See, so we have less than. So this is our definition. So let me write. So according to this definition, so we have absolute value of x less than a, or since we have equals to, let me add equals to. Now we can rewrite this as a x greater than equals to negative of a less than equals to positive of a. So this is the definition we will use to rewrite this absolute value inequality in terms of linear inequality. So at first, write down whatever you have inside this absolute value of sign. So we have x minus 4. Okay, then less than or equals, sorry, greater than or equals to. So greater than or equals to negative of this number, negative 15. Then less than or equals to on the right, less than or equals to positive of this number, which is 15. So this is how we can rewrite absolute value inequality in terms of linear inequality. So this is a very key step. Okay, once you have this correct, then we have the linear inequality and we know how to solve this one. Okay, any question on this part? And I will give that definition on your exam. Okay, now let's solve this inequality. Solving means we have to make x by itself. Now x has negative 4 with it, so let's get rid of negative 4, and to get rid of negative 4 we add positive 4. Make sure you are adding on a both side, including that middle expression. So then we have negative 15 plus 4, that is negative 11, less than equals to x less than equals to 6, so that's 19. Now how do we read this inequality? So we have x by itself, it means we have a solution here. Now how do we read this solution? So what is solution here? What kind of number is solution for this inequality? How to read that final solution? X, so every number, so x is any number. Okay, so any number which is greater than or equals to negative 11 and less than 19 are the solution for this inequality. Now let's draw a number line. We always write down the solution in an interval notation. So we have negative infinity, positive infinity. So negative 11 here, positive 19 here. Now we have equals to sign here. Okay, so we have equals to sign. So close circle at negative 11. We have equals to sign here. So close circle at 19. Close circle means these two numbers are also the solution. Okay, now where do we find a number x which is greater than negative 11 and less than positive 11? So we have three portion here, so three part of a number line. So on which part we find a number which is greater than negative 11 and less than positive 19? Where do we find those numbers? In part 2, right? So every number, so this part is our solution. Now let's write an interval notation for this part. So this region is starting from negative 11 and ending at 19. So at 11 it's a closed circle, means we use a bracket. At 19 closed circle means we use bracket, and this is the solution for this inequality. So every number greater than equals to negative 11 and less than 19 are the solution for this absolute value inequality. Okay, any question? Okay, now let's go to the next one. So here we have absolute value of 3s plus 2 is greater than equals to positive 6. Okay, now we all know this is absolute value inequality. Now once you know its absolute value inequality, you have to check what type of inequality sign we have. We have greater than or equals to. Okay, so we have greater than, and if it's greater than, we have a different definition. So in part A we had a less than, so we use this definition. Now if it's greater than, okay, so if we have absolute value of x greater than, let me add equals to a, then its definition is, if we go back to our definition, then we have x less than negative a or x greater than positive a. So x less than negative a or x greater than positive a. So this is the definition. Okay, so we use this definition to rewrite this absolute value inequality in terms of linear inequality. Now can you use this definition? So how to use this definition? So how can we rewrite this absolute value inequality in terms of linear inequality using this definition? So at first we have, so x less than negative a, right? So x means everything inside absolute value sign. What do we have inside absolute value sign? 3s plus s, sorry, 2. So write down 3s plus 2. Then since we have equals to, do not forget equals to, I'm sorry, so this is equals to here, this is equals to here. So write down everything, whatever you have inside absolute value sign, which is 3s plus 2, then less than equals to negative of this a. So our a is 6, so negative 6, or do not forget or, then x is what is inside absolute value sign, which is 3s plus 2, then greater than equals to positive of a, which is positive 6. So this is how we can rewrite. Now this is linear inequality, so let's solve each of these inequality. So solving for s, so you subtract 2 on both sides. So we have 3s less than equals to negative 8. Now we need to get rid of 3 by dividing by 3. So 3s divided by 3 is s less than equals to negative 8 over 3. We divide by positive number, so inequality sign, it remains same. Okay, it does not change. Now in the similar way, let's solve this one. So you subtract 2 on both sides. So we have 3s greater than equals to 4. Then let's get rid of 3 by dividing by 3. Then we have s greater than equals to 4 over 3, and do not forget or. Okay, so we have or here. Okay, so now what is the solution? So this is our solution. We have s by itself, so we have the solution. Now from this solution, can you tell me what kind of number are solution for this inequality? What kind of number is solution for this inequality? So every number, so s is a, so number which is less than negative 8 over 3 is a solution, or number which is greater than 4 over 3 is a solution. Now can you think of a number which is less than negative 8 over 3? Can you think of a number which is less than negative 8 over 3? Like negative 10. So negative 10 is a solution. Or also number which is greater than 4 over 3, like 5. 5 is a solution. Now let's write this solution in an interval notation. For that we draw a number line. Okay, so we have negative infinity, positive infinity, then we have negative 8 over 3, let's say somewhere here. We have positive 4 over 3 on the right side somewhere here. Now we do have a equals to sign. Okay, we do have a equals to sign, means it's a closed circle. Do not forget, it's a closed circle. Also we have equals to sign at 4 over 3, so close circle at 4 over 3. So we have 3 part. Okay, now where do we find a number which is less than negative 8 over 3? So where do we find a number less than negative 8 over 3? In which part? Part 1, right? So every number on the left is solution. Similarly, where do we find a number which is greater than 4 over 3? On the third part, every number on the right of 4 over 3. Now, these two, yellow region and a green region, these two are solution. Now, let's write an interval for each part here. Now, what will be the interval for yellow part? How do we write down interval for yellow region? You always start from the left number, right? So what do we have on the left? Negative infinity and all the way up to negative 8 over 3. Now with infinity it's always parenthesis. Now with negative 8 over 3, do we use parenthesis or a bracket? Bracket. We have a closed circle, bracket. Okay, now we have a or here. Okay, so or we use union sign when you are using interval notation. Or is same as union. Okay, do not forget or is union and is intersection. Okay, that's what we had when we did a review. So we replace our or by union. Now let's write interval notation for a green region. So it's starting from 4 over 3, right, ending at positive infinity. With infinity it's always parenthesis. Now at 4 over 3 we have a closed circle, it means bracket. So this is the solution for this absolute value inequality. So every number less than negative 8 over 3 or every number greater than 4 over 3 is the solution for this absolute value inequality. Okay, any question on this part? Okay, now let's go ahead and do number C. So in part C, what do we have? We have 2x minus 3, absolute value of 2x minus 3 is greater than positive 7. Now, our inequality has a greater than. So which definition do we use? Do we use the first definition or second definition? Second, right? It's very similar to number B. So let's use this definition. Okay, so using the same definition, so we will use the same, exactly same definition, because we have a greater here, we have a greater here, so we will use this definition. So according to this definition, you write down whatever you have inside absolute value sign, which is 2x minus 3. So let me erase this for a while. So we have to write down 2x minus 3, then less than or equals to. We do not have equals to here. You simply write down less than negative a. Your a is 7, so negative of 7 is negative 7, or do not forget or. Okay, then write down x. X is everything inside absolute value sign, which is 2x minus 3, then greater than a, positive a, which is positive 7. Okay, any question in this very first part? This is the very most important step. Okay, once you have this correct, the remaining is a linear inequality. Okay, now let's solve each of these inequality. So you add 3 to get rid of 3. So we have 2x less than negative 4. Then you divide by 2. Our x is less than negative 2. Now let's solve another inequality. You add 3. So we have 2x greater than 10. Then divide by 2 on both sides. So our x is greater than 5. And do not forget or. So this is the solution. Okay. So what is the solution? Every number less than -2 or every number greater than 5 is a solution. Okay, so if our x is less than -2 or x is greater than 5, then those numbers are solution. Now let's write down this solution in interval notation. You draw a number line, negative infinity, positive infinity. So we have -2. So let's say -2 is somewhere here, positive 5 somewhere here. Now there is no equals to sign. So at -2, open circle. So there is no equals to sign at 5. So open circle. So let me call this is first part, second part, third part. Now where do we find a number x which is less than -2? Which part? On which part do we find a number less than -2? It's on the first part. Everything on the left of -2. So this is the first part of a solution. The next part of solution is x greater than 5. So greater than 5 means every number on the right of 5. So these two are solution. Now let's write an interval notation for each of this region. So for green region, it's starting from -infinity, ending at -2. Okay, with infinity, always parenthesis. -2 has open circle, so parenthesis. We have or, so replace or by union. Then for yellow region, it is starting from +5, ending at infinity. With infinity, always parenthesis. At 5 we have open circle, means parenthesis. And this is our solution for this absolute value inequality. Any question? Now let's do our number D. Okay, now can you read what we had in number D? Did you say -4? So -4 plus absolute value of 3 minus x, then less than 5. Okay, then less than okay, so okay, see greater than +5. Okay, now so here can we start by using definition for part D? Now if we go back to our definition, we use our definition if we have absolute value of some expression greater than or less than equals to positive number. But on our case we have a -4. Okay, so we do not have absolute value expression in one side, so we need to make absolute value sign expression in one side and the remaining, so these two are like terms. So let's collect these two terms together. So let's get rid of -4 by adding 4 on both sides. So we have absolute value of 3 minus x is greater than 9. Okay, so before you use the definition, you must have your absolute value expression in one side and the constant on the other side. Okay, now we can use the definition. Now which definition do we use? Is it first definition or second definition? Did I hear first or second? Second. Now how we know? It depends on what inequality we have. So we have greater than. Okay, so greater than means, see, so we have greater than, so we will use this definition, very similar to the one that we just did in part C. Okay, so using that definition, you write down whatever you have in absolute value sign. We have 3 minus x, then less than negative of this number, -9, or write down the same expression, 3 minus x greater than positive of that number, +9. Okay, so we use the second definition. Now let's solve each of these inequality. So we subtract 3 here. So this is -x less than -12. Now we divide by number, -1. And what happens if we divide our inequality by negative number? We flip, we switch this inequality. So we have less than, so we write down greater than -12 divided by -1 +12. Okay, in the similar way, let's solve another inequality. You subtract 3 on both sides. So we have -x greater than +6. Then we need to get rid of negative by dividing by -1. So we have +x. Do not forget to flip here because we are using negative number to divide. So less than -6, and we have or. So this is the solution for this inequality. So every number which is greater than 12 or every number less than -6 is the solution. Now how do we write this in an interval notation? So you draw a number line. So we have -infinity, +infinity. Now we have -6 and +12. Negative number has to be on the left, right? So this is +12. And we do not have equals to sign, so open circle at -6, open circle at 12. Okay. Now where do we find a number which is greater than 12? So it's on the right side, right? So this is one solution. Next, where do we find a number less than -6? It's on the left of -6. So this green region and yellow region are the solution. So we write down an interval. For the green region, it's starting from -infinity, ending at -6. With infinity, always parenthesis. At -6, we have an open circle, that is parenthesis. We have a or, so we replace or by union. Now yellow region is starting from 12, ending at infinity. With infinity, parenthesis. At 12, open circle, parenthesis. And this is the solution for this absolute value inequality in an interval notation. So you do not need to memorize the definition, okay, but you should know how to use that definition. And once you use that definition, the remaining is simplifying the linear inequality, which is our section 1.5. Okay, any question? All right, now let's go to the next one. So here we are asked to graph the following on a number line and write each set using an absolute value inequality. The set of all x whose distance from 4 is less than 5. Now how do we write this in a absolute value inequality form? So we have set of all x whose distance from 4. Now how do we write down the distance? So how do we find the distance? So to find the distance, we find the absolute value of our difference. Okay, so we need to find the difference of x and 4. So difference of x and 4 is x minus 4, and absolute value of this difference is a distance. Okay, so that's how we define in our review section. So to find the distance between any two number, we find absolute value of our difference of those two number. Okay, so here we have a x, one number, second number is 4. So the distance of x and 4 is absolute value of x minus 4. This is the distance. And less than 5. Now what kind of inequality is this? Less than means this is the less than and 5. Okay, so this is the distance between x and 4, and we have a less than, so this is less than, and 5 is 5. Okay, in a similar way, in number B, the set of all x whose distance from 4. So distance So set of all x whose distance from 4. So what is that distance? X minus 4, that is the distance, is greater than, so is greater than 5. So this is the absolute value inequality. So absolute value of x minus 4, that is the distance. And for greater than, we have this inequality, and 5 is 5 here. So this is how we can write this statement in absolute value inequality. Okay, and we can solve this and graph as we did in part A. Okay, any question in this part? Bless you. Okay, now let's go to our very last example. A thermometer measures temperature with an uncertainty of, I'm sorry?
The total graph of the number line.
Yes, so this is an inequality, right? Now we have this inequality and we know how to solve this inequality, right? Like so we solve here ABCD. So you solve using very similar to ABCD and graph your solution like we did in a number line.
So what to do that?
So okay, I wanted to skip this part here. Now using the definition, I want you to try solving this inequality. Okay, like very similar to this ABCD. Okay, now here we have a less than, means we use the first definition, and here we have the greater than, we use the second definition. Okay, once you have the solution, you graph, and it's very similar to number A. Okay, now let's go to number 3. So here a thermometer measures the temperature with an uncertainty of 0.25 degree Fahrenheit. Now what does this mean? So thermometer measures the temperature with an uncertainty of 0.25 degree Fahrenheit. What does this mean? So if the thermometer has uncertainty of 0.25 degree Fahrenheit, what does this mean? So if for some person's body temperature is 98.3 degree Fahrenheit, then we need to write an inequality for the range of possible body temperature. So if the temperature measured by that thermometer whose uncertainty is 0.25 degree Fahrenheit is 98.3 degree Fahrenheit, now what can you say about the body temperature? Is the body temperature exactly 98.3 degree Fahrenheit? We are using the thermometer whose uncertainty is 0.25 degree Fahrenheit. Now it means the person body temperature can be 98.3 degree Fahrenheit plus 0.25 degree Fahrenheit or minus 98.3 degree Fahrenheit. Okay, so let's call our x as a temperature, and this x can be greater than or equals to 98.3 minus this uncertainty 0.25 or less than equals to 98.3 plus 0.25. It means the body temperature can be less than negative 0.25 or it can be more by 0.25. And we have to use the absolute value notation. Okay, now for that we subtract 98.3, subtract 98.3. So this is 0, this is 0. So we have negative 0.25 less than equals to x minus 98.3 less than equals to 0.25. Now we have this definition. So if we have x greater than equals to negative a less than equals to positive a, then we can rewrite this as a absolute value of x less than positive a. So this is our, so if we have this definition, then we can rewrite this one. So this is the one that we use to solve the absolute value inequality. Okay, we are just going in the reverse direction. So this is absolute value of x minus 98.3 less than equals to 0.25. and this is the absolute value inequality for the possible body temperature. So we use the very first definition of solving an absolute value inequality.